Get the key info on big new developments without wading through everything.
Exactly. And today, well, we're diving into something really mind-bending.
Which is?
Living AI. Biocomputing. It sounds like sci-fi, but it's happening.
Right. I saw the source material. Brain cells playing video games. Seriously. And companies building, like, biological computers.
That's the core of it. So our mission today is basically to unpack this. What's real? What's the potential? And, the big questions it throws up.
Okay, let's jump right in. That Pong thing, that really caught my eye. Human brain cells playing Pong.
Yeah, back in 2022, a company called Cortical Labs, they made something called Dish Brain.
Dish brain.
Imagine like 800,000 human neurons, actual neurons, living cells spread out on a microchip.
Okay.
And yeah, they taught these cells to play a simplified version of Pong.
How? I mean, how does a dish of cells learn?
Well, this is the fascinating part. They learned by minimizing unpredictable stimuli, basically reducing surprise.
Reducing surprise.
Yeah. Think about how you learn, like catching a ball right. You adjust your movements to make the outcome, catching the ball, less surprising, more predictable.
Okay.
These neurons did something similar. They tweaked their connections to get better at predicting where the Pong ball would go, making the stimulation they received more predictable.
Wow. Okay. That's pretty amazing. But why? With all our silicon chips, why go biological?
Well, a huge factor is efficiency, energy efficiency.
Right.
Your brain runs on, maybe 20 watts, like a dim light bulb?
Yeah, something like that.
Now, a supercomputer trying to do complex tasks, similar sorts of processing, it can pull 40 megawatts?
40 million watts compared to 20.
Exactly. The difference is just enormous. So there's this huge potential energy saving with biological systems.
That makes sense. And there are limits to silicon anyway, aren't there?
Absolutely. We're kind of hitting a wall. Transistors are getting down to the size of, single atoms. It's physically hard to go much smaller.
So we need alternatives.
Yeah.
And this wetware is one possibility.
It is. And it's not just theoretical labs anymore. There are companies actually doing this.
Like who?
Well, there's Final Spark over in Switzerland.
Okay, Final Spark. What are they doing?
They're creating these tiny 3D clusters of brain cells. They call them brain organoids, mini brains, basically.
Mini brains. Okay.
And get this, they offer cloud access to these organoids for researchers.
You can log in to a brain organoid?
Sort of, yeah, for research purposes. It's small scale now, but there's real global interest picking up.
That's kind of wild.
Yeah.
And Cortical Labs, the Pong people, are they commercializing?
They are. They're planning to launch their CL1 bioprocessor, I think, 2025.
A bioprocessor. So an actual product people can buy.
Yeah, though it's aimed at researchers initially. Makes the whole thing feel much more, tangible, less like pure science fiction.
Okay, so faster, more efficient computing is one angle. But the source material mentioned medical uses too.
Oh, absolutely. And this could be huge. These brain organoids, they're becoming really valuable tools for studying neurodegenerative diseases.
Like Parkinson's.
Alzheimer's.
Exactly. You can model aspects of these diseases in the organoids. Researchers are actually testing things like memory retention in diseased mini brains compared to healthy ones.
Wow. So you can see the disease process unfold at a cellular level.
Potentially, yeah. It offers a window into understanding these conditions that we just didn't have before.
Okay, that's a clear benefit.
Yeah.
But teaching living tissue to compute, to think in some basic way, doesn't that open up a whole can of worms, ethically speaking?
It absolutely does. And researchers in the field are grappling with this. One was quoted asking, very directly, you have to ask, can I kill them?
Oh, can I kill them? Should I? That really stops you.
It does. It highlights this completely new ethical ground we're stepping onto. We're merging biology and computation in a way that forces these questions.
Even if they aren't, conscious or self-aware like us.
Precisely. We're nowhere near creating sentient biological computers, let's be clear.
Right.
But the questions about how we treat these systems, what our responsibilities are, they're already here. Yeah, you don't have to wait for full AI consciousness for the ethical questions to start.
Not at all. It's early days, definitely. But this convergence, biology, And computing, it's fundamentally changing things. Science, ethics, even how we define intelligence itself.
So the takeaway is, this is happening. It's moving from labs to potential products, and it carries both massive potential and really deep questions.
That sums it up pretty well.
Okay, so here's something to chew on then. Forget the exact timeline for a moment, whether it's 5 years or 50. How might our actual definition of a computer change in the decades ahead? If biology becomes part of the hardware, what new responsibilities does that put on us?
That's the big question to ponder, isn't it? What does it mean when our technology starts to become alive?